Section 15C, question number 1, page 369. Question 1 asks us to use the product rule to differentiate. And we've got a few functions to deal with. But let's first remind ourselves of what the product rule actually is. So just over here to the side, suppose we have f of x being equal to u of x times v of x. Then the derivative, or the gradient function, will be the derivative of the first, u prime of x, multiplied by the second function, plus the first function multiplied by the derivative of the second function. And then from there you would just simplify. If we're using Leibniz notation, and we know that y is equal to u times v, then dy by dx equals du by dx times v, so the derivative of the first times the second, of course the derivative of the first with respect to x, plus the first function again multiplied by the derivative of the second, dv by dx. And then after we get that, we would then simplify. Okay, so let's take a look at part A, where we have f of x equals x, quantity x minus 1. So there's nothing really to rewrite there, so we can just go ahead and take the derivative of that. So f prime of x. So the first function is x, the second function is x minus 1. So the derivative of the first is just 1. And we multiply that by x minus 1. And then we take the first and multiply by the derivative of the second, and in this case it will just be 1. And we just simplify this a little bit, so we get x minus 1 plus x, and then we end up getting 2x minus 1 as the final gradient function, or the final derivative. Question B is f of x equals 2x, quantity x plus 1. Again, the important thing is to identify which are the two functions that are being multiplied together. And then when you take the derivative, remember we take the derivative of the first times the second, and then we add that to the first multiplied by the derivative of the second. So the derivative of the first would be 2 multiplied by the second, x plus 1. Then we add the first times the derivative of the second, which is just 1 in this case, and then we simplify here. So we bring this in and we get 2x plus 2 plus 2x, simplify by collecting like terms, so we end up getting 4x plus 2. In part C, f of x is defined as x squared multiplied by the root of x plus 1. So we need to rewrite the root of x plus 1 into exponent form. So we get x plus 1 all to the exponent 1/2. And then now we'll go ahead and take the derivative. So f prime of x, the derivative of the first, which is 2x, multiplied by the second, which is x plus 1 to the exponent 1/2. Then we add the first function multiplied by the derivative of the second, and so we bring that half down in front. Now using the chain rule, bring the half down in front, subtract 1 from the exponent. We leave the inside as it is, so a half minus 1 gives us negative a half. And then we take the derivative of the inside of that, and actually maybe let's do that right here, even though it's not really necessary, but because it's just the derivative of x is just 1, doesn't really make a huge difference there, or actually a difference at all. So then we can just kind of tidy things up a little bit, so we get 2x multiplied by x plus 1 to the 1/2. That 1 multiplied by half is just a half. I'll bring that outside here, so I get 1/2 x squared times x plus 1 to the negative a half. And then I'll factor out the lowest power of the common factor. So I get x plus 1 to the negative 1/2 factored out, which leaves us 2x, and then when you divide x plus 1 to the 1/2 by x plus 1 to the negative 1/2, we just then end up getting x plus 1. And then when you divide this by itself, you just get 1, so you're left with 1/2 x squared. And so then in the next step, I'll return this to the same form as it was originally there, and because it's a negative exponent, that'll drop into the denominator. At the same time, I'm going to multiply this into that bracket. So I get 2x squared plus 2x plus 1/2 x squared all over the root of x plus 1. And then I'll just bring together the like terms there. So I have 5/2 x squared plus 2x all over the root of x plus 1.